Welcome back, our dear learners, and thanks for following. Please subscribe. QuestLift is on Google Play Store. Look for that app, subscribe, such that you can always pick up these lessons as they flow. Last lesson we talked about the two common types of series which we give enough justice in discussing them. We talked about the arithmetic progressions and fully gave it enough justice, and we introduced some bits of the geometrical progressions where I said that if you have a series, say 2, 6, 18, 54, and so on. If you look at that series, critically, the first term is a 2. Now, going on to the next term, you need to multiply. You keep multiplying by 2 in the previous term to get the next one, and so on, and so on. For instance, from 2, which is our first term, the next one is a 6. So I've multiplied by a common number 2, so a common number 3. Now that common number 3 is again multiplied by 6 to get 18. The same common number 3 is multiplied by 18 to get 54. So the common number being multiplied to generate the next terms is called the common ratio. And generally, if A is the first term and R is the common ratio, then we can generate a series. As below, i.e. our first term is A. It is being followed by, to get the next term, that is after A, to get the next one, we have to get the first one and multiply it by the common ratio R. And to generate the next one, you get the previous one, which is AR, and you multiply it by r. To generate the next one, it is AR times R times R, and so on. Now, if I'm to rewrite it properly, I have A plus AR plus AR squared plus AR cubed, and so on. Such a series is said to be progressing, geometrically. Said to be progressing geometrically. Is said to be progressing geometrically. Is said to be progressing geometrically. And for any number of terms, we have our general expression or our general series as we have A plus AR plus AR squared plus AR cubed plus up to plus AR to the power n minus 1 up to plus AR to the power n minus 1. Now, I've said that A is the first term. I've said that A is the first term. I've said that R is the common ratio. Then the term AR to the power n minus 1 or is called the nth term stroke last term of a geometric progression. I.e. UN is equal to AR to the power n minus 1. Here I've said it is the nth term, and sometimes it can be called the last term. Why? The reason is here. Remember, we talked of infinite and finite series. If a series is finite, that is, it has got an end, it has a stopping point. That last term is the one I'm referring to. So it can either be the last term if we have a finite geometrical series, or it can be the nth term. So it depends on the circumstance. So for instance, Iggy, for the series 2 plus 6 plus 18 plus 54 and so on, find U10. Now U10 means you are looking for the 10th term. So from UN, which is A to the power n minus 1, we have U10 as the first term is a 2. Now R, I've said how do you get R? You get these two subsequent terms, you divide one by the other. You get 6 divided by 2. It can be 18 divided by 6. They will both generate a 3. It can be 54 divided by 18. You still get a 3. So the first term, which is A, is 2. Our common ratio is 3. Then to the power n is 10 minus 1. So you have 2 times 3 to the power 9. So you can use your calculator. You start by getting 3 power 9. 3 power 9 is, this is 2 times 1, 9, 6, 8, 3. So the result, you multiply it by 2, and the final answer is going to be 3, 9, 3, 6, 6. So why these two series? Why do we need to look at them specifically? You will be at a very big task to determine the 10th term of this series, because it cannot be done manually. Yes, you can do it, but it is ambiguous. You will find it very hard to do it. So that is why we opt for a simpler way of trying to come up with some of these things without getting issues. Now, let us continue and we talk about the sum of the first n terms of a geometrical progression. Sum of the first n terms of a GP. GP is the abbreviation, short term of geometric progression. The short term of geometric progression. Now, if I let Sn to be the sum of the n terms of a GP, then my Sn is equal to A plus AR to the power n, plus AR squared plus AR cubed. I can go up to there, then plus up to plus AR to the power n minus 1. I have that one there. Now, I can fix a term before the last term. I can fix a term before the last term. I can have Sn is A plus AR squared plus AR cubed plus. Now, if this is the last term, the term before it is AR to the power n minus 2, then plus AR to the power n, which is the last term. Now, I can call this equation 1. From there, I can multiply equation 1 by R. Why am I multiplying? Remember, I've said that these geometrical terms are created by multiplying each term by a common factor R, which is called the common ratio. So if I multiply this here, I'll end up with R Sn. R multiplied by Sn, I will get this is equal to, if I multiply here, this one gives me AR. If I multiply this one gives me AR squared. If I multiply here, I'll get AR cubed. If I multiply here, I'll get AR to the power 4 plus. Now, if I multiply this with this, some of you get challenged there. Let me show it to you. You have AR power n times R power negative 2. That is from indices. This is where this one comes from. Same bases, add the powers. That's why you end up with this. Now, I can still rewrite it as AR to the power n over R squared times R. Remember, I'm multiplying by R. So one of the R's disappears, and I will end up with AR to the power n. Now, if I shift the n back up, I'll get a minus 1. So this one, if you multiply it by R, you end up with AR to the power n minus 1. If you multiply R here, that is the last term, it will become AR. If you follow what we have tried to do the other side, remember, A times R to the power n minus 1 is the same as AR power n over R. So if you multiply it by R, one R disappears with the other one, which is down, and you remain with AR to the power n. Now, after this, I can call this my equation 2. So if I call it my equation 2, I can get equation 2 and take off equation 1. If I get equation 2 and take off equation 1, what do I get? I want you to follow critically well. My equation 2 is this one. I'm going to subtract it vertically. So I have this minus this. Let's subtract it vertically, but in a corresponding order. This with this, that means I remain with RSN minus SN is equal to. Now, what you are going to see is this one can go with that. This one can go with that. This one can go with that. There is also a term. Remember, these dashes are talking of terms I've excluded because of space. There is a term in AR power 4, which is here and up there. So I have this one crossing out with a term which I have not written here. Then I have another term before this, which is going to cross with this. I also have this crossing with this. So what is the magic? The magic is if you subtract here, the result or the end result is you remain with the last term and the first term. You only remain with the two terms. It is the last term, so you'll have A R to the power n minus A. That is the magic. Now from here, the common factor is Sn. So if I pull out Sn, I'll remain with R minus 1 is equal to the other side. I have A as a common factor. This is R power n minus 1. So from there, if I am to make Sn the subject, my Sn is now becoming A into R power n minus 1 over R minus 1. That is the formula for the sum of the first n terms. Now, something unique is still there. Something unique is still there. I want to emphasize it. I've subtracted equation 1 from 2, or it is 2 minus 1. What if I get equation 1 and take off equation 2? If I get 1 minus 2, I have Sn minus R Sn minus R Sn, which gives me A minus A to the power R. If I factor out to the common factor, it is Sn into 1 minus R. This is A into 1 minus R to the power n, and Sn is 1 minus R to the power n over 1 minus R. We are going to continue from there.